Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we're going to do a crash course in how to simplify square roots. And as always, if you want to follow along with this worksheet, you can find it at the first link in the description below. Okay, so when we're talking about how to simplify square roots, it's helpful to first remind ourselves, first of all, what square roots are, but also what perfect squares are. So for example, let's look at the perfect square tables here. 1 squared is 1. That means 1 times 1 is 1. 2 squared is 4, because 2 times 2 is 4. 3 squared is 9, because 3 times 3 is 9, and so on. So we talk about these numbers and these numbers as being perfect squares. Okay, that means that there is a whole number that when it's squared results in that number. And of course, there's an infinite number of them. They keep going past 14, but just for the sake of the table and keeping it small, I just included up to 14. So when we talk about perfect squares, we're talking about those numbers, and it's helpful just to memorize them, just to commit those to memory. Okay, now square roots are sort of the opposite, right? The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, and so on. And essentially what you're asking, like for example, the square root of 9 is 3. What you're asking is, what number squared gives you 9? That's what a square root is. In this case, it would be a 3. The square root of 16 is 4. The square root of 25 is 5. It's just the backwards or the inverse of the perfect squares. Square roots, squares, they go, they're inverses of each other. Okay, so let's use that to try to answer some of the questions that it's asking in this worksheet. So let's take a look at numbers 1 and 2. There's not a whole lot going on in number 1. It just says to simplify, and it's got the square root of 16. In other words, what number times itself gives you 16? And of course, you can look at the table, or you might have this memorized, but the answer is 4, because 4 times itself gives you 16. Okay, now how about one like number 2, where it has the square root of 9 over 100? Well, according to the rules of square roots and how this works, you can actually break that fraction up into 2 separate square roots. Let me show you what I mean. I could rewrite this as the square root of 9 over the square root of 100. Those are just according to how square roots work. Okay, well, what's the point in doing that? Well, think about it. The square root of 9, that's a perfect square. So we've got 3, and the square root of 100, well, that's also a perfect square. That's 10. So the final answer there is 3/10. So if you have a situation like that where there's a fraction underneath the square root symbol, you can always separate it into the numerator and denominator, each having a square root, and then evaluate each one of those separately. Before we go any farther, go ahead and pause the video and let's see you try numbers 3 and 4. Assuming you've had a chance to do that, let's now take a look at numbers 5, 6, and 7. So now we're going to sort of put together some of the things that we've learned so far. This number 5 says 5 times the square root of 9 minus 4. Well, as it turns out, luckily for us, the square root of 9 comes out even. That's a perfect square. So the square root of 9 is 3. So instead of writing that as 5 times the square root of 9, I'm going to write 5 times 3 minus 4. So all I did there was I replaced square root of 9 with 3, with what the square root of 9 is. It's 3. Well, now, according to order of operations, I just go left to right, and I'm going to do my multiplication first. So 5 times 3 is 15. So this turns into 15 subtract 4, which of course is 11. So final answer there is 11. So sometimes you'll have a square root symbol in the middle of the equation, and you just have to know what order to evaluate them. Okay, now what about something like number 6? Notice under the square root symbol, we have 30 subtract 14. You actually need to go ahead and do that subtraction problem first. So instead of 2 times the square root of 30 minus 14, what is 30 minus 14? Well, that's 16. I still have that plus 7 over here. Okay, how does that help us get to a final answer? Well, 16, if you take the square root of 16, you get 4. So really what this turns into is 2 times 4 plus 7. Again, all I did was evaluate the square root of 16 as 4. Well, now we can do this with some mental math. 2 times 4 is 8, plus 7 is 15. Okay, so just a quick and easy way to get the final answer. You just have to know some of these rules of what you can and can't do with square roots. And in that case, if you have even an addition or subtraction problem underneath the square root symbol, you need to go ahead and take care of it first. Number 7 is a good example of that. So let's just kind of skim through this and see if there's anything that we can simplify. Let's take a look at the first term, the 3 times the square root of 64. If you have these memorized, your perfect squares or your square roots memorized, you'll know that the square root of 64 is 8. So we could rewrite that as 3 times 8. But what are we going to do with that situation where we've got the square root of 38 plus 11? Well, since it's all underneath the square root symbol, what is 38 plus 11? It's 49. So I could rewrite that as the square root of 49. We're almost there. 3 times 8 is 24. And what's the square root of 49? Well, if you look up at the table or if you have it memorized, hopefully you know that that is 7. So really all this breaks down to is 24 plus 7, which of course is 31. Okay, so I'm going to go ahead and once again, let's pause the video and I want you to try numbers 8, 9, and 10, and we'll pick up below that. Now, assuming you've had a chance to do that, let's take a look at number 11. It says the square root of 18. Now, if you look at the top of the worksheet, 18 does not appear up there. It's not a perfect square. There's nothing that works out evenly with it. But if we know the rules of square roots, we can kind of get a little shortcut here that's going to make our lives a little bit simpler. If I think about the factors of 18, the things that multiply together to get 18, I have 1 and 18, I have 2 and 9, and I've got 3 and 6. Okay, so I could rewrite 18 as any one of those factors. I'm going to strategically pick 9 and 2. 9 times 2 is 18, right? And the rules of exponents say that you can, of square roots say that you can rewrite the square root of 18 as the square roots of any of its factors. So the square root of 9 and the square root of 2. But why did I pick 9 and 2? I could have used 3 and 6 or 1 and 18. Well, the reason that I picked 9 and 2 is because 9 is a perfect square. The square root of 9 is 3. So I can rewrite this as 3 times the square root of 2. And although it feels kind of weird, that's actually your final answer, 3 times the square root of 2. And the reason is because we've simplified this into terms that are as simple as they can get. In other words, sometimes you'll hear math teachers say, like, we've pulled out any of the perfect squares out of the number 18. Square root of 2, can't simplify that any further. I mean, you could get a decimal representation of it, an approximation, but for now, let's just leave it like that, 3 times the square root of 2. Okay, let's take a look at number 12. There's lots of factors of 48. There's lots of factor pairs. We could do 1 and 48. You could do 2 and 24. You could also do 3 and 16. And when I'm going through those factor pairs, when I said 3 and 16, 16 kind of goes off in my mind because that's a perfect square. I'm going to rewrite this instead of the square root of 48. I'm going to rewrite it as the square root of 16 times the square root of 3. Okay? Now, the reason that I picked those again is because as I was kind of looking above, I noticed that 16 was a perfect square. So what is the square root of 16? Well, it's 4. So this, in its simplest form, would be 4 times the square root of 3. And sometimes you'll see them just listed side by side. Sometimes you'll see the little dot in the middle, but 4 times the square root of 3 is as simple as it gets. Okay, let's do one more kind of similar to that just to show you kind of what can happen in one of these problems. So we have 7 times the square root of 12. 12 is not a perfect square. So then I start thinking about its factors. So you've got 1 and 12, 2 and 6, 3 and 4. And when I say 4, that kind of goes off in my mind because 4 is a perfect square. Here's how I'm going to rewrite this. Can't do anything with the 7 yet. He's still just kind of hanging out in front. I'm going to rewrite the square root of 12 as the square root of 4 times the square root of 3. 4 times 3 is 12. I picked that factor pair specifically because 4 is a perfect square. So square root of 4 is 2. So really this turns into 7 times 2 times the square root of 3. Okay, now we're done except that we can evaluate 7 times 2 is 14. So in its most simplified form, this would be 14 times the square root of 3. Okay, so there's just a couple of examples of how you can simplify square roots. Now, hopefully this video was helpful, and if it was, consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.